Solution 1. Today we want to discuss about the vapor pressure of pure solvent and that of solutions. Now for this purpose we have to discuss about the solubility, that is solubility of gaseous in liquid, solubility of solid in liquid, solubility of liquid in liquid, and solubility of solid in solid, and solubility of gaseous in gaseous. Now it is very necessary to tell about the solubility. Solubility is the amount of solid particles gets dissolved in a pure solvent at certain temperature is known as the solubility. And the solubility of gases depends on the pressure exerted on it. If you increase the pressure, then the solubility of the gases increases. This occurs through the law of Henry. And according to Henry's rule, the amount of gaseous particle dissolved in a liquid is directly proportional to the pressure exerted on it. That is, X varies as P, and P is the pressure exerted and X is the amount of gas. And if the pressure increases, the amount of gas is dissolved, there is more, or X equal to KHP. KH is the Henry's constant. This is the solubility of the gases, and solubility of gases depends on the temperature. If temperature increases, then the solubility of the gases decreases. And it also depends on the gas liquid attractive force. There is attractive force between gas and liquid molecules, and this is the solubility of the gases in liquid. Now we have to discuss about the solid in liquid. If solid particles get dissolved in a pure solvent, then a homogeneous mixture is obtained. This mixture is known as the solution. And the solid particles are the solid and the solvent are the liquids. The amount of solid particles gets dissolved in a liquid depends on the temperature. If you increase the temperature, then more amount of the solute, that is the solid solute, gets dissolved in a liquid. And it also depends on the nature of the solid particles. If the intermolecular force of attraction of the solid particle, solvent solid particles, and solvent particles, and if the solid particles are weaker, then more amount of solid gets dissolved in a pure solvent at certain temperature. And there is also the liquid in liquid. If you add some alcohol in some water, then a solution is obtained. This solution is known as the liquid solution. And if a solid is mixed in another solid, then a mixture is obtained, that is the homogeneous mixture, and this is known as the alloy. As for example, the bronze or duralumin or any other alloys are the solid solutions. If you mix a gas in another gas, then a gaseous mixture is obtained. This is known as the gaseous solution. Now we have to discuss about the vapor pressure. Now we have discussed about the vapor pressure. What is the definition of vapor pressure? If some amount of liquid, some amount of pure solvent is taken in a closed vessel, that is partially filled, the vaporization occurs. If the rate of vaporization and the rate of liquefaction is equal, then the pressure exerted on the liquid is known as the vapor pressure. And there is an equilibrium, or an equilibrium is established there. At that state, the pressure exerted by the vapor is known as the vapor pressure. The vapor pressure of a pure solvent, the vapor pressure of a pure solvent is always higher than that of the solution. The vapor pressure of a pure solvent depends on the intermolecular force of attraction of the solvent molecules. If the intermolecular force of attraction of the solvent molecules are weaker, then the vapor pressure is greater. If you increase the temperature of the solvent, then the intermolecular force of attraction weakens, and the more the water molecules get evaporated and the vapor pressure increases. That is, the vapor pressure of a pure solvent depends on temperature and that of the nature of the solvent. If the temperature is high, then vapor pressure is high, and if the intermolecular force of attraction between the solvent molecules is low, then vapor pressure is high. This is the vapor pressure of pure solvent. The vapor pressure of pure solvent is expressed as the vapor pressure is written as P naught, pressure of pure solvent. If you add some solid particles in a pure solvent at certain temperature, the vapor pressure decreases. This is because the surface of the solution is occupied by less solvent molecules, and thus the rate of the evaporation is low. If the evaporation is low, then the vapor pressure is low. That is, if you add some solid particles in a pure solvent, the vapor pressure of the solution produced is low. The vapor pressure of solvent, the vapor pressure of solution, if you write as P, this is the vapor pressure of solution, this is the vapor pressure of pure solvent. And there is a law that is the Raoult's law, and Raoult's law states that at certain temperature the vapor pressure of a solution is equal to the product of the vapor pressure of pure solvent and the mole fraction of it. That is, P is equal to P naught 1 x1, where P is the vapor pressure of solution and P naught 1 is the vapor pressure of pure solvent, and x1 is the mole fraction of the solvent. If you write P naught 1 vapor pressure of a pure solvent and x1 is the mole fraction of solvent. This is the law of Raoult's, that is the Raoult's law. This is applicable only for dilute solutions. Applicable only for dilute solutions. If the solution is very dilute, then the Raoult's law is appropriate. And this is only for the dilute solutions and for the ideal solutions. For ideal solutions. Ideal solutions. This is about the solid solute in liquid. But if you add a liquid in a liquid, that is, the solution is formed by two liquids. The two liquids are volatile. Then the vapor pressure of the solution, that is solution of two liquids, or the vapor pressure, that is vapor pressure of the solution, P is equal to P1 plus P2. And P1 is equal to P naught 1 x1, P2 is P naught 2 x2. P naught 1 is the vapor pressure of the pure solvent, and x1 is the mole fraction of pure solvent. P naught 2 is the vapor pressure of pure solute, that is volatile solute, and x2 is the mole fraction of the of the volatile solute. That is, the vapor pressure of the solution is equal to the partial pressure of the two volatile liquids, and this is equal to P1 plus P2. This is according to the law of partial pressure. This is according to the rules of partial pressure. And where P1 is the P01 x1 and P02 x2. If you draw a graph, for this, for the solvent only, then if you plot the vapor pressure along y-axis and mole fraction along x-axis, then a straight line is obtained. If the x1 is 0, now if you increase the x1 0 to x1 equal to 1, that is, vapor pressure increases as the mole fraction of the solvent increases. Now the graph is like this, and this is the P01 and x1 is 0. Now if you increase the x1 value, then the vapor pressure increases and it becomes high at x1 equal to 1. This is the pure solvent and this is the vapor pressure of pure solvent. Now if you consider the vapor pressure of the two volatile liquids, that is the solution of two volatile liquids, then the graph is like that. The vapor pressure along y-axis and mole fraction along x-axis. The substances are volatile. If you take x1 equal to 0 and x2 equal to 1, x1 equal to 0, if you increase x1 equal to 0 to x1 equal to 1, then the vapor pressure of pure solvent becomes this, that is P0, P01. And if you the x2 equal to 1, if you decrease x2 from 1 to x2 equal to 0, then the vapor pressure decreases. Initially it was P02 and it is P01. Now if you add the line, then a total vapor pressure P equal to P1 plus P2 or P01 x1 plus P02 x2. This is the vapor pressure of a solution formed by two volatile liquids.